When you look up at the night sky, you probably picture stars
Right.
and planets going around them, maybe even life out there.
That's the standard image, definitely.
Yeah.
The classic solar system model.
But what if? What if we've been looking in maybe the wrong places? Or at least not all the places. What if life could exist somewhere completely unexpected, like in total darkness?
You're talking about rogue planets. It's a fascinating kind of mind-bending area of astrobiology right now.
Exactly. That's what we're diving into today, these rogue planets just wandering through space, no star to call home.
And it's not just a few oddballs either. The numbers are potentially staggering.
Right. I was amazed when I first read about this. Some estimates based on gravitational microlensing surveys, they suggest there could be billions of them. Billions.
Wow.
Maybe even more rogue planets than stars in our galaxy.
It's an incredible figure. That Mars paper from 2020 really highlighted the sheer scale. It forces you to rethink the galactic census, basically.
Absolutely. So the big question for this deep dive, the one that's really got me thinking is, could these cold, dark, seemingly, lonely worlds actually harbor life?
That's the billion-dollar question, isn't it? Or maybe the billion-planet question.
Okay, so let's back up a bit. What exactly is a rogue planet? I mean, okay, no star. But how does that happen? Are they just born that way?
Well, there's sort of two main theories, One idea is they get kicked out, ejected from their home solar systems early on.
Like gravitational chaos, planets bumping each other around.
Pretty much, yeah. Imagine a young solar system, lots of big planets jostling for position. Sometimes one gets flung out entirely, cosmic pinball.
Okay, and the other idea?
The other possibility is that they form completely on their own, like from a collapsing cloud of gas and dust that just wasn't quite massive enough to ignite into a star. A kind of failed star, maybe, or just a solitary planet from the start.
So cosmic orphans or solitary hermits, and again, potentially billions of them. It expands the map so much.
It really does. But, the obvious challenge comes up immediately.
No star, no sunlight, right? Isn't that like rule number one for life as we know it? No energy.
That's definitely the traditional thinking. Our whole concept of the habitable zone, that Goldilocks region around a star where liquid water could exist on the surface, it all hinges on stellar radiation.
So rogue planets are just out. Frozen wastelands.
Not necessarily. This is where it gets really interesting. Rogue planets force us to think beyond that star-centric habitable zone. We need to consider other possibilities for warmth and energy.
Okay, I'm intrigued. If not sunlight, then what? How does a planet floating in, deep space avoid becoming just an ice ball?
There are a couple of key possibilities. First, internal heat. Planets generate heat internally, from the leftover energy of their formation.
Like when all the rock and stuff slam together.
Exactly. And also, crucially, from the decay of radioactive elements in their core, this can be a really long-lasting heat source.
Okay. Internal furnace, basically.
Sort of, yeah. And this heat could potentially keep things warm enough deep down, maybe even warm enough for liquid water under the surface.
Wait, that sounds kind of familiar, like Jupiter's moon Europa. Doesn't it have an ocean under the ice?
Precisely. Europa is probably the best analogy we have in our own solar system. It's believed to have a huge subsurface ocean kept liquid not by the distant sun, but by internal heat, partly radioactive decay, partly tidal forces from Jupiter's immense gravity.
Okay. So rogue planets wouldn't have the tidal heating part because there's no big planet nearby.
Right, no Jupiter squeezing them. But the internal heat from formation and radioactivity alone could, theoretically, be enough for some of these larger rogue planets to maintain a subsurface ocean for billions of years.
Wow. Okay, so hidden oceans warmed from within. That's one possibility. Are there others? Any other way to stay warm out there?
There's another really cool idea. What if the planet had an incredibly thick atmosphere, particularly one rich in hydrogen?
Hydrogen. Like the gas.
Yeah. David Stevenson pointed this out back in 1999. Hydrogen, under enough pressure, can be a surprisingly good insulator, like a planetary duvet.
Huh. So a super thick hydrogen blanket could trap that internal heat, keep the surface, or maybe just below the clouds, warm enough.
That's the concept. It could potentially trap enough of that geothermal heat escaping from inside to maintain liquid water. Maybe not on the surface directly exposed to space, but perhaps beneath the atmosphere or within it.
A dark world wrapped in a warm hydrogen haze. That sounds pretty wild. Is that, physically plausible?
The physics works out, yeah. It depends on the planet's mass and composition, of course, but it's a possibility. And then there's a related idea. Maybe not a thick atmosphere, but a very thick ice crust.
Ice. But wouldn't that just make it colder?
You'd think so, but think of an igloo, right? Ice can actually be a fantastic insulator. A thick enough ice shell over a subsurface ocean could shield that ocean from the extreme cold of interstellar space, trapping the internal heat inside.
So the ice itself acts like the blanket in that scenario. Okay, so we've got potential liquid water, either under ice or maybe under a thick atmosphere, warmed from the inside. But life still needs energy, right? Photosynthesis is out without a sun.
Absolutely. No sunlight means no photosynthesis, as we typically think of it, but Earth itself shows us another way.
You mean like down in the deep ocean?
Exactly. Think about deep-sea hydrothermal vents. Pitch black, immense pressure, no sunlight reaches down there, yet they are teeming with life.
Yeah, those weird tube worms and crabs. How do they survive?
Chemosynthesis. Instead of using light energy, the microbes at the base of that food web use chemical energy. They metabolize minerals and chemicals like hydrogen sulfide, spewing out from the vents which originate from the Earth's crust.
So they're literally eating rocks or chemicals from rocks.
In a manner of speaking, yes. They're harnessing chemical energy released by geological processes. Entire ecosystems built on chemistry, not sunlight.
Okay, so if Earth can do that in its dark oceans,
Then why not a rogue planet? If a rogue planet has that internal heat we talked about, it likely has geological activity. Maybe even hydrothermal vents on the floor of its subsurface ocean.
releasing the chemicals needed for chemosynthesis.
Precisely. It provides a plausible energy source for life, completely independent of a star. Life in the dark, powered from below.
That really, really broadens the possibilities.
Yeah.
It's kind of mind-blowing. But, okay, let's get practical. How on Earth, or off Earth, would we ever find life on one of these things? They're dark, they're probably far away.
Yeah, that is the massive challenge. Detection is incredibly difficult. Just finding the planets themselves is tough because they don't shine. We mostly find them indirectly now.
Like that microlensing thing you mentioned earlier.
Exactly. Gravitational microlensing is our best bet currently for finding them, especially the smaller ones. Basically, if a rogue planet drifts in front of a distant star, its gravity bends the starlight in a way we can detect. Like a cosmic magnifying glass, briefly.
So you see the star behind it get weirdly brighter for a bit.
That's the gist of it, yeah. And the upcoming Nancy Grace Roman Space Telescope is specifically designed to do a lot more of this microlensing surveying. It should find many more rogue planets.
Okay, so we can find them, hopefully more easily soon. But finding the planet isn't finding life. How do we look for life itself?
That's the next hurdle. Once we find some promising candidates, especially any that might pass relatively close by, the James Webb Space Telescope, JWST, might give us some clues.
How? Can it see through the ice or clouds?
Not directly through thick ice, no. But if a rogue planet has one of those thick, heat-trapping atmospheres we discussed, JWST is incredibly sensitive to infrared light, which is basically heat radiation.
Ah, so it could detect the planet's own heat signature, even if it's faint.
Potentially, yes. And even more excitingly, it might be able to analyze the composition of that atmosphere, if it has one. It could look for certain gases.
We got biosignatures,
Yeah.
gases that might indicate life.
Exactly. Things like methane or ammonia in combinations that seem out of balance with purely geological processes. Detecting those could be a smoking gun, or at least strong circumstantial evidence for biological activity. It's a long shot, but possible.
Wow, detecting the faint chemical breath of life on a dark, wandering world. And what about, like, sending a probe way down the line?
That's very much future tech. A flyby mission to a rogue planet is theoretically possible, especially if one happened to drift near our solar system, but the navigation and timing would be incredibly complex. You're trying to intercept a small, dark object moving through interstellar space. Not easy.
Yeah, it sounds like getting a needle in a haystack in the dark from light years away.
Oh.
Okay, but let's just imagine, what if we did find life? Even just microbes. What would that discovery mean?
Oh, it would be revolutionary, utterly paradigm shifting for astrobiology and maybe for humanity's view of itself.
How so?
Well, first, it's definitive proof. Life does not require a star. That's huge. All our models based on stellar habitable zones would need a massive update.
So the habitable zone concept just gets way bigger, or maybe fuzzier.
Exactly. It suggests habitability isn't just about proximity to a star, but also about internal conditions. It implies that potentially habitable environments, these subsurface oceans, could be incredibly common throughout the galaxy, maybe far more common than Earth-like surface environments.
Luck means life itself could be much more common.
It strongly suggests that, yes, If life can arise and thrive in these dark, isolated environments, then the galaxy might be absolutely teeming with life in places we've barely even considered looking.
That also makes me think about, you hear about panspermia, right? The idea that life could spread between planets or even stars.
Yes, the idea that life isn't necessarily confined to its planet of origin.
Could rogue planets play a role in that? Like, could they pick up microbes from one system and carry them to another?
It's a fascinating speculation. If a planet with microbial life gets ejected, could that life survive the journey dormant in the subsurface ocean? Could it then seed another system if the rogue planet gets captured or passes through a protoplanetary disk? Rogue planets could potentially be galactic seed spreaders.
Wow. So these lonely wanderers might actually be connecting the galaxy in terms of life. That really flips the script, doesn't it? From desolate outcasts to potential couriers of life.
It certainly adds another layer of possibility. It suggests life might be more interconnected, more resilient, and frankly just more prevalent than our sun-focused view has maybe led us to believe. Life thriving in the dark.
So something for everyone listening to really chew on. Is it really possible that whole biospheres exist on planets lost in eternal night, teeming oceans we can't see?
Does this potential force us to rethink what life even means, or at least where its boundaries lie?
And if these planets are truly as common as stars, maybe more common,
Yeah.
what does that tell you about life's abundance in the cosmos? And I suppose about our own little bright spot here.
They're big questions. The universe might be far stranger and far more alive than we've imagined. Perhaps the biggest discoveries aren't waiting for us in the light, but hiding out there in the cold, quiet darkness between the stars.